Good afternoon all. From my behalf, I'm Iiris Viljamaa from FMI, and I'll go with you to check the weather in Europe at the moment. I'm actually working in safety weather group here in Finland, and I'll do this presentation so that I will show you how I will check the weather in Europe, for example, in the beginning of my shift. So this is just showing different methods how I check the weather. First of all, I want to open my SmartMet tool, and normally I open some data from ECMWF. That's a really common model I use here. And here I already opened one screen with air mass temperature in colors. And then there's a contour of isobars, or is this actually 500 hectopascal height. So here we see at the moment 12 UTC today that there's upper low system near to Iberia Peninsula on west, and then there is another more deeper low level low pressure system over the southern Sweden, and on northern Atlantic there looks like a high at the moment. And then I go in time steps 12 hours forward, and I'm following how the disturbance move. This low pressure here moves to east over Baltic countries, and then other low is moving slowly over the sea here. And actually this pattern allows very cold air to flow to Central Europe, and on coming week from Monday it looks like even here in Western Europe it's very cold air mass. Also in the beginning of next week it's look like pressure gradient in northern Scandinavia and Finland. It's really strong, and it affects strong winds in our country, northern parts. So this is the first step of my briefing. I might be interested about how cold it actually is on coming week here in Western Europe. And for that one, I opened 2 meters temperature weekly mean anomalies. And I can see that the anomaly of the temperature is even -3 to -6 on coming week in this area. Even though we here have very windy weather and it might not feel warm at all, this chart indicate warmer temperatures than typical here, and we actually are accepting firm winds over the Scandinavian mountains to affect the temperatures in western parts of Finland. Also, I want to see some observations, and I'll probably check first some of the satellite images. This is here we can see the low pressure in the same places in southern Finland, and then another one here somewhere north of Spain. Also, what else could I do? I can check from SmartMet different parameters. We in safety weather, we are really interested about the possible warnings that we have to issue, and those are mainly about strong winds or some precipitation. Here you guys can see maximum gust from the past 24 hours in ECMWF model. And for example, today, because of the low pressures, we have really strong winds here on the sea, and then, for example, in Denmark. Okay, here I will continue. Here we have strong winds and storm winds in yellow or red color. And I'll go through, we see that on Sunday the winds will be strengthening in the Mediterranean Sea area a lot. Also this low system who is moving through Baltic countries is making wind very strong here. And then in the beginning of next week, another really deep low system is moving here in Iiris, and it's causing really strong winds here in Scandinavian northern parts.
Hello.
On the other tab, I have a similar view, but here I have precipitation, actually rain in millimeters. And then I can check if some area is needed to give a weather warning. In Finland, of course, in my point of view, but then now we want to check the European weather. So we see that especially this southern low system is causing a really heavy rain on the coastline of Croatia and other countries of here. And because of the cold air mass, I probably want to check also which part of this rain is coming in snow. And then I might need another tab for snow accumulation. Here is actually accumulation not only 24 hours, but 120 hours, meaning 5 days accumulation. And we see that even in Morocco, mountainous areas, they will see snow fall in coming days. So that's basically what I do. And then as a result in my work, specifically, we will use the SmartMet alert tool, which helps us to put the warnings that we want to issue in the sea areas of Finland, and also then here in the land areas. I hope you liked my presentation. It was short and not so well prepared, I would say, but it's interesting to see how this group will discuss, and I'm also happy to answer some questions if they are easy enough for me. Do you have some questions about the European weather?
I would suggest, if it's fine for you, Iiris, that we keep all the questions for the end of the weather briefing,
Okay.
and give the word now to Leila, and then at the end we will have a discussion.
Okay, my name is Leila Hieta. I'm from Finnish Meteorological Institute. Also, I used to work as a weather forecaster for around 10 years, but now I have been working with post-processing of weather forecast, and I'm currently working. Sorry?
Please, I need to ask the audience, please, to be quiet as long as the presenters are talking. We can have a discussion in the end, but please mute yourself for now and give the presenters the chance to speak. Thank you.
Okay, I'm currently working with the post-processing of operational weather forecasts. And I'm going to tell you how we have lately been using satellite information to produce total cloud cover nowcast. So a little bit about the motivation and the background. So previously the nowcast information was updated to our operational weather forecasts manually by our on-duty forecasters using tools in our SmartMet meteorological workstation. But of course, this caused a delay before the information actually reached the end users, which is actually quite crucial when we're talking about nowcast information. So we decided to create a method to automate this nowcast production. So we developed a SmartMet nowcasting system to produce the nowcast information for the key parameters. And this system was automated in 2021. It's a known fact that we can improve the quality of the numerical weather prediction models nowcast information by combining observations in the beginning of the data, and this is what the SmartMet nowcast system is doing. So it can use different information sources, for example, recent observations, nowcast information derived from observations and numerical weather prediction nowcast model data, and then seamlessly blend this nowcast information with the operational forecast, and then it's easily used in our end production. Here is one example of our very popular end product. So this is a screenshot taken from our public webpage. You can see a meteogram for Helsinki. Of course, the user can choose a point of interest of her or his. But in here, you can see the forecast for following hours, and the first hours of this information is then automatically updated with the SmartMet nowcast system. As I said, it was developed for key parameters at first, but we knew that total cloud cover is difficult because we need to have a good quality observations, preferably in grids. So it took us a while to develop a system to produce the total cloud cover nowcast information, but it's now the latest addition to our SmartMet nowcast system. So the total cloud cover nowcast is produced by using a neural network. It took us about a year to develop the system, and it's been operationally or automatically updated to our production since January this year. So it's a rather new addition. The satellite product that we are using is nowcasting SAF effective cloudiness. I think most of you are familiar with the nowcasting SAF software products, but effective cloudiness is definitely not the most known one. But this is what we wanted to use because it's similar what the numerical weather prediction models are producing for total cloud cover. So this product equals to 1 for thick clouds and has values between 0 and 1 for semi-transparent clouds. In the picture here on the left-hand side, you can see the effective cloudiness field, and on the right-hand side, you can see a numerical weather prediction total cloud cover parameter. I will be using this similar visualization in my following examples also. So the thick or the hatched dark green areas are 100% of cloud cover, and the yellow bordered areas are cloud-free areas, and the shades between are then the different cloud cover values there. But this was the visualization I chose, so I'm able to plot this on top of the satellite information. The neural network is a UNet neural network model. It was developed by my colleague Mikko Partio. It's based on 2 years of this nowcasting SAF effective cloudiness data. It's used as training data. I won't go into details of the neural network architecture in here, but I will be concentrating more of this effective cloudiness product itself. But the neural network produces 3-hour forecast with 15-minute time steps. We have been overall very pleased with the quality of the effective cloudiness, but there are some quality issues, and we have developed a post-processing method to improve the quality or correct these problems in effective cloudiness. Most of the quality issues are caused by our very northern location. So I marked Finland there. I think this is very familiar picture of many of you. So this is the cloud mask product from the geostationary Meteosat satellite. We need to use geostationary satellite data in our neural network because we need to have a good time series of data for trading and for same domain. So that's why we cannot use polar orbiting satellite information as they are. But I remember as a young forecaster, first time seeing this kind of real image of what the geostationary satellite actually sees. And I was wondering that however we can use satellite information in Finland, but we are using it all the time in our daily work. And it's surprising how good the quality is, even though we are on the very border of the observation area already of the geostationary satellite, and the resolution is rather poor already in northern Finland. But the quality issues in effective cloudiness, they of course depend on seasons because weather change. During summer times, when we have a lot of cumulus clouds, we have noticed that effective cloudiness quite often sees them as 100% of cloud cover. So we need to find a way to detect these convective cases and reduce the cloud cover. A bigger problem was that during cold season, the effective cloudiness sometimes totally misses the thin low-level clouds and falsely interprets them as clear skies. Sometimes we can notice that between the boundaries of high and low-level clouds, there are these strands of cloud-free areas, which are falsely interpreted. And also, of course, which is very common, that there are some problems caused by twilight, but these problems weren't as severe as we first expected when we checked the data more carefully. I will be using this 24-hour microphysics RGB a satellite image produced by Meteosat. This is something that we use very often in Finland because we don't have much visible light during wintertime. So we need to have a satellite product that works during dark time also. So this is very commonly used, but let's go quickly through, maybe this is familiar with most of you, but let's quickly go through the interpretation. So tricky thing about this product is that the surface color changes depending of the surface temperature. So if we are in a more warmer climate, the surface is more bluish colors, which is marked here in number 9. And then if we are more of a cold temperatures, which is more often the case in Finland, then the color is more red, which is marked here as number 8. Which is really nice feature in this product is that the low-level clouds really pop out. So they are marked in yellowish color here in number 1. So those can be really easily distinguished between the cloud-free areas. Then the colder clouds are marked as darker red color, which is here number 3. This is sometimes tricky in Finland because it easily gets mixed with very cold surface. And then the high-level thin cirrus clouds, if there is no other clouds below those, they are marked with really dark blue or even black colors. So this is the satellite image I will be mainly using in my examples. So first of all, the cumulus clouds problem in effective cloudiness. So here in the left-hand side image, you can see the 24-hour microphysics satellite image in the background, and on top of that, on the left-hand side, is the effective cloudiness product. And on the right-hand side, you can see the numerical weather prediction nowcast model, total cloud cover for the same time. And in this one, we can see that it's not very easy to see. This example is from late August, so the convection in Finland is not very strong, but you can see the clear ground is shown as more bluish color, so it's not very cold yet. The convection is not very strong anymore in Finland, normally in this time or closer to autumn already, but you can faintly see that there are these yellowish colors seen in the central Finland, but the numerical weather prediction model totally misses these shallow cumulus clouds, whereas the effective cloudiness can capture these, but then it produces a bit too much cloud there, so the cloud cover is mostly 100%. So we have been using numerical weather prediction shortwave radiation information to then try to reduce the cloud cover where we have cumulus clouds in the products. But it's a nice thing that the effective cloudiness was able to capture these cumulus clouds, whereas the numerical nowcasting model was not. Then we can move on to another common problem that we have with the stratus clouds. So in this example, you can see it's colder because the surface is now red. This example is from January. So on the left-hand side, you now have the kind of the post-process or corrected effective cloudiness product. And on the right-hand side, you can see the original effective cloudiness. And I've marked here in pink circle an area where the effective cloudiness totally misses these low-level clouds, which seem to be rather thin because the yellowish color is not very strong. So it's interpreting it as a cloud-free area, even though it's cloudy. So we are using the numerical weather prediction model information of low cloud cover and relative humidity, and also the nowcasting SAF cloud mask quality information to add to find these areas where it's falsely interprets clear skies, even though it isn't. And we have added in this post-processed version some cloud in that area. But on the other hand, in central Finland, in these areas which I have marked with light blue circles, we are at the same time adding some cloud cover there, even though effective cloudiness is correct. So these kind of corrections are always some kind of trade-off, that they might work in some cases, but then you need to be careful not to make the quality of the product worse. So it would be nice to be able to use only satellite information, because of course, if the numerical weather prediction model is wrong, it also causes us to make the original satellite product worse. But we need to certainly have something, because this is actually quite a big problem during winter time in Finland. So here is one example of the neural network forecast itself. So the upper panel is the neural network-based nowcast. The 0 hour of this nowcast information is the effective cloudiness itself, because we are using it as the observation analysis of total cloud cover. Then the lower panel is a numerical weather prediction nowcasting model. And of course, in the background, you can see the satellite image. This is a zoomed in picture in southern Finland. You can see the Gulf of Finland and also Estonia in these images. And then on the next columns, you can see the following hours, like 1 hour forecast and 2 hour forecast. And if we are checking the nowcast total cloud cover information in the upper panel, we can see that it quite nicely captures the edge of the boundary of the cloud, which is seen in the background as a yellowish color. There is this low-level cloud mostly covering the southern Finland, so it can quite nicely capture where there is cloud, but it's actually not getting totally 100% as it should, but it's still rather well, even after 2 hours, capturing the cloud itself, whereas the numerical weather prediction model is not working very well in these situations. And we have noticed that this using this observation information in the beginning of our forecast really improves the forecast quality, especially during wintertime, when we quite often have these low-level clouds, which are very difficult to forecast for numerical weather prediction model. Okay, this was my very last slide. So thank you, everyone.